On one fine day, Intan and Yasmin found Yana, Yan, and Nana at a cafe busy with something big, and they decided to join them.
I heard that you guys are discussing the suitability and stability of frying oil. Can you guys explain more about it?
First, suitability of oils for frying is also known as inherent stability. It is calculated from the level of each of the USFA and their relative reaction with oxygen. Yan, do you have anything to add on?
I just want to say that the higher the inherent stability, the less stable the oil for frying.
The example of oils that are not suitable for deep frying are liquid seed oil such as soybean oil and seed oil. This is because these oils are partially hydrogenated to shortening, which can cause the oil to be plastic solid.
Crispiness of fried products depend on the solid content.
I have a question. So, how to measure the stability of frying oils and fats?
There are 3 accelerated tests that can be applied. The process is quite simple and easy to understand, and the first type is AOM.
So, basically, what do you want to measure in this test?
The aim of these 2 tests is actually to measure the PV, or better known as peroxide value.
Yeah, so that's how AOM and skull test works.
So, what's the difference between those 2 tests?
The difference is the temperature used for both tests.
We have been studying about oil stability tests, specifically the Ransimate method, and we were wondering if you could shed some light on it. We find it quite intriguing.
Good morning, Alice, Batrisyia, and Diyanah. I am glad to see your interest in oil stability tests. The Roshaimi method is indeed available tools in assessing the oscillative stability of oil. And I'd be more than happy to discuss it with all of you. Where would you like to begin?
Thank you, Dr. Farhah. To start, I'd like to understand the underlying principle of the Ransimate test. How does it work and what does it measure?
Great question, Diyanah. The Ransimate test determines the resistance of oil to oxidation by subjecting them to elevated temperatures and a constant flow of air. The main principle is to accelerate the oxidation process under controlled conditions. It measures the induction period, which is the time it takes for the oil to reach a specific conductivity limits, indicating the onset of oxidation.
That's fascinating, Dr. Farah. Can you explain the significance of this test in terms of practical terms and how does it impact industries that use oils?
Absolutely, Anis. The Roshaimi test is crucial for industries that rely on oils, such as food, cosmetic, pharmaceutical sector. By evaluating the oxidative stability, they can assess the shelf life and quality of oils used in their products. It helps ensure that the oil will not deteriorate rapidly, preserving their sensory attributes and nutritional value, and maintaining the overall product integrity.
That makes sense, Dr. Farhah. Can you explain the procedure involved in conducting the Ransimate test?
Certainly, Batrisyia. The Ransimate test consists of several steps. First, we accurately weigh a sample of the oil and place it in a reaction vessel. Then the oil is heated to a predetermined temperature while a stream of air is passed through it. Conductivity changes resulting from oxidation are measured continuously, and the induction period is determined by the time it takes for the conductivity to reach the predefined limit.
I am intrigued by the data analysis part. How do we interpret the result obtained from the Ransimate test?
Excellent question, Diyanah. The data obtained from the Ransimate test is typically analyzed in the term of induction period. A longer induction period suggests higher oxidative stability, while a shorter period indicates lower stability. By comparing the result of different oil samples, researchers and industries can make informed decisions about selecting oil with the desired stability for their specific applications.
Doctor, are there any factors that can influence the results of the Ransimate test? I'm curious about the variable involved.
That's a great question, Anis. Indeed, Several factors can impact the result of the Roshaimi test. The quality of the oil, its composition, and even the presence of antioxidants can influence the oscillative stability. Additionally, variation in the test conditions such as temperature and flow rate can affect the result. It's essential to control this variable and maintain consistency when conducting the test.
Thank you for explaining, Dr. Farhah. We have learned a lot about the Roshaimi test. Is there any additional reading materials or experiment we can explore to deepen our understanding?
Absolutely, there are additional resources and experiments that can enhance your understanding of the Roshaimi test. I can provide you with research papers and scientific articles that dive into the topic in more detail. Furthermore, we can plan a practical experiment in the lab where each of you can perform the Roshaimi test on different oil samples. The hands-on experiment will give you a comprehensive understanding of the procedure and its outcomes.
Sounds fantastic, Dr. Farhah. We will love to get some hands-on experience. It will definitely help solidify our understanding of the Roshaimi test.
Absolutely. I'm excited to see how different oils perform under the Roshaimi test and understand how stability varies among them.
Thank you so much, Dr. Farhah. Your guidance and the opportunity for practical experiments will undoubtedly deepen our knowledge of oil stability testing. We truly appreciate it.
You are most welcome, Anis, Batrisyia, and Diyanah. It's always a pleasure to see students enthusiastic about scientific exploration. Let's schedule a lab session and I will provide you with the necessary materials and guidance to conduct the Roshaimi test. Remember, curiosity and hands-on experience are essential in mastering any scientific concept.